Hello and welcome to Simcyp-R e-learning video. For this video, we're going to be talking about the Simcyp Simulator version 21 R package, and we're also going to talk about how one can save simulation results to a database file. So the first thing we're going to do is to introduce the Simcyp-R package. Then we're going to talk about how one can identify Simcyp parameter tags. This is important to know as it allows you to modify and extract parameter values within a Simcyp workspace. After this, we're going to talk about how one can extract simulation results from a database file. And finally, we're going to run through a version 21 Simcyp-R demo script. So what is the Simcyp-R package? To have an understanding of what the package is also important that we know and understand the Simcyp architecture. Simcyp is made up of three different components. The first is a screen, which you use to build your PBPK model. Then once you're happy, you can then save your model to a workspace. And then finally, to make your model predictions, we use the engine to run the simulation. So because the engine is separated out from the screen and the workspace, this allows room for interoperability. There are many compound and population databases and thousands of model combinations within the Simcyp simulator that can be accessed by other platforms such as MATLAB and R. The benefit of interoperability is that it expands the interaction between various groups, and it also integrates the PPK models in workflow. So this is why we have the Simcyp-R package. Simcyp-R package makes the connection between R and the Simcyp simulator engine. Okay, so what is needed in order to run a Simcyp-R script? The first thing you need to do is to make sure that you have Simcyp Simulator version 21 installed on your local machine. Then you also need to install R statistics, at least version 4.0.2. And then finally, you need to install the Simcyp-R package. The package name for this is Simcyp 21.0.100, and this is a zip file. Once you've done that, you can now start to write your Simcyp-R script. In order to do this, the first thing that you need to do is to first of all create your workspace, and this can be done by simply opening up Simcyp Simulator, then saving a file to a workspace. Once you've created your workspace, the next thing that you need to do is to install version 21 R package into R. Once that is done, the next thing that you can do is then to initialize Simcyp within R. To initialize Simcyp within R, we use the function called initialize. And for this function, you need to specify the file path for the Simcyp simulator engine. And then within this function, you can also choose which species you want to initialize to. So in this example, we're using species ID to say that we want to initialize to the human simulator. If let's say you're interested in initializing to the animal species, you can specify that the species ID, for example, can be the rat simulator. So this will initialize to any of the species available within Simcyp. Once you've initialized the Simcyp engine, you can now import your workspace that you're interested in working with. So in this example, we use the function called setWorkspace to import a workspace, and we can see that the workspace name is called Metropolo Custom Dosing. And with this, we also specify the Simcyp extension. Once you've ran this function, what happens is that in your R console, a summary of that workspace is reported. So we can see for this workspace, the compound, so the substrate was Metropolo, which uses first order absorption and minimal PPK for the distribution model and enzyme kinetics for the elimination. And within this workspace, 100 milligrams was given to healthy volunteers between the age of 20 to 50 years old. So this can be used as an indication to make sure that you've imported the right workspace. After you've imported your workspace, you can now run a simulation. To run a simulation, we use the function called simulate, and within this function, you then need to specify the database file name. So once we've ran this function, for example, a database file called custom dosing will be created within the folder that you're working in. So I just have an on here as an extra is that after, let's say you've imported your workspace, you can also choose to modify your workspace. So if let's say you're interested in changing a parameter value within the workspace that you're interested in, for example, maybe the molecular weight, you're not happy with it, you can choose to change the value of the molecular weight from R without having to open up the Simcyp workspace. Once you've made all the changes that you're happy, you can then now run your Simcyp simulation. So this slide here is to show the important functions that are necessary in order to lay the foundation for your Simcyp-R script. On screen now, you can see the list of functions available within the Simcyp-R package. Here I'm going to describe the functions that are commonly used when writing a Simcyp-R script. The first group of functions are the getters. These functions, for example, you can see have the word get before the function name. So for example, get compound parameter, get dose, get parameter, get PD parameter, get population parameter, get solver, get simulation toolbox parameter. What these functions do is that they go into the workspace that you've brought into R, and they are able to get the values or parameters used within that workspace. So if let's say you've forgotten the molecular weights that was used within the workspace, you can use get compound parameter to go into that workspace to extract the information of the molecular weight. Or another example is that if you have forgotten the dose amount that was used within a workspace, you can use the function called getDose to go into that workspace to see what the value of the dose is. The next set of parameters are the setters. These all have the word set before their function name. So for example, set dose, set parameters, and so on and so forth. So what these functions are used for is that they are used to change parameter values within the Simcyp workspace that you brought into R. So for example, if you're interested in changing the molecular weight value, you can use set compound parameter to change the molecular weight value. Or if you're interested in changing the dose value within the workspace that you brought in, you can use the function called setDose to change the dose value within that workspace. The next group of functions are the DB functions. These functions have the term DB, which stands for database, at the end of each function. These functions are used to go into the database file that was created to extract the simulation results that was generated. So for example, if you're interested in knowing what the simulated age for each individual is, we use the function called getIndividualValue to go into that database file and extract the age value for each subject. Or if let's say you're interested in extracting the concentration profiles that was generated for each subject, we use the function called getProfileDB to go into that database file to then extract the concentration profile for each subject. The next group of functions are functions which are used to extract simulation results from memory. From version 20, we introduced legacy mode, and this has to be set to true in order to extract simulation results from memory. For example, if you are interested in extracting the concentration time profiles generated for each subject, we use the function called getProfile, not getProfileDB. And getProfile is used to extract simulation results from memory. The reason why these functions are highlighted in orange is because the Simcyp simulator has stopped further development and testing on storing simulation results to legacy mode. So now the focus is on exporting results to database, Excel, Phoenix, or a CSV file. For this reason, we've also stopped the development of extracting simulation results to legacy mode. And we also strongly advise that any previously written scripts that you may have created to adapt these scripts to extract simulation results from database instead. So now we're going to talk about how one can identify Simcyp parameter tags. The first way to identify Simcyp parameter tags is via the Simcyp GUI. On here we can see that we are interested in changing or knowing what the value of FA is that is used within the workspace. To know what this value is from R, we use the function called getCompoundParameter. For this function, you need to specify the tag ID as well as the compound ID. So in order to know what the tag ID is, all you need to do is open up a Simcyp workspace, go into the parameter that you're interested in. So for example, in this case, it's FA. Then you right click on the input box. Within this drop down menu, you will see a tag ID listed at the top. Clicking on this ID value will copy this value to clipboard. Then you can then come into R and then paste this value within the function. Once you've pasted or specified the tag ID, you then need to specify the compound ID for this function. So in this case, we're interested in the substrate FA value. So we want to know what is the FA value that is used within the substrate. If I was interested in knowing the FA value used in the inhibitor, then the compound ID in this case will be inhibitor 1. Once that is done, you may choose that you want to change this FA value. Um, to change the FA value, we use the function called setCompoundParameter. And for this function, you also need to specify the tag ID. So the tag ID remains the same. Then you also need to specify which compound do you want to change. So in this case, we want to change the substrate FA value. And then finally, you need to mention the value that you wish to change this parameter to. So in this example, we are changing the FA value to 0.5. Once that is done, you can then rerun the getCompoundParameter function to just check that the change has been made. Below here is another example using a population parameter. So assuming you were interested in knowing what the BSA C1 parameter value is from R, the tag ID for this parameter is ID BSA C1. So how I obtain this information is by right-clicking on the input box, and then I have this drop-down menu where I can click on this to then copy this tag ID to clipboard. In order to extract this value, we need to use the function called getPopulationParameter. The difference between this function and the previous function is the word compound and population. So the BSA, for example, is found within the population tab, hence why we're using the function named getPopulationParameter to extract this information. However, FA value is found within the compound tab, hence why we use a function named setCompoundParameter to extract the FA value. So for the getPopulationParameter function, you need to specify the tag ID. In this case is ID BSA C1. Then you need to specify the population ID. To then maybe change the BSA C1 value, you can then use the function called setPopulationParameter to change this value. Another example that I'm demonstrating on screen is if you're interested in changing any PD parameter within your workspace. So for this, you use the function called getPDParameter function, and you need to specify number one, the tag ID, the compound ID, and finally the PD level. The PD level is always going to be set to 1, and this is because the selection within the output transduction type is always assumed is going to equal to none. So we are not feeding into, for example, the PD response link model or to another basic PD response model. So for example, if you're interested in maybe changing the Emacs value for within your workspace, you use the function getPDParameter, then the tag ID. As I mentioned previously, you can go into a Simcyp workspace, right click on the input box, and the tag ID will be listed in the drop down menu. You can then copy this over and paste this within your R script, and then you need to specify the compound ID that you wish to change. Once you've done that, you can also choose to change these parameter value. To change the parameter value, we use the function called setPDParameter, and you need to specify the tag name, the compound ID, the PD level, and finally the numerical value that you wish to change this to. Once you've done that, you can then rerun the getPDParameter function to just check that your change has been made. Another way to identify a parameter tag is by using parameter estimation and sensitivity analysis. How this works is that once you open up a workspace, in this example, we are using KA and VSS for demonstration. So you can go and select these parameters, let's say for parameter estimation. Once you've done that, you can then save your workspace and then bring this workspace into R. Once you've brought the workspace into R, we then use the function called listParameter. Having the value 0 within this function will spit out the parameter tags of any parameter that you've selected for parameter estimation. So in this case, we selected KA and VSS, hence why we see at the bottom the tag ID for KA is ID KA, and the tag ID for VSS is ID entered VSS. If, let's say, VSS was selected for sensitivity analysis instead, we can run list parameter function but change this value 0 to 1, and that will spit out or list out any parameter that was selected for sensitivity analysis. So once you've identified what the tag names are, you can then use your set parameter function or your set compound parameter function to change the values of these parameters. Another way of identifying parameter tag ID is by using FindEnum function. For this function, assuming you were interested in knowing what the molecular weight tag is, we know the molecular weight is first of all found within a compound tab. So you need to first of all mention where you think this parameter is located in. What object do you think this parameter will be situated in? So in this case, in this example, I have an idea that is going to be found within the compound parameter ID object. Then once you've specified the object, then you need to mention as a string what characters you think will be within this tag. So in this case, I've just typed out MOLE, are most likely going to be the characters that are found within this parameter tag. Once I've ran this function, what then happens is that within your console is going to spit out any parameters that has the character MOLE inside of it. So as you can see, within a compound parameter ID object, we have molecular weight, ID MW, and we also have molecule type that has the character MOLE within it. And we also have the molecular radius as well as molecule state. So what's happened here is that the FindEnum function has gone into the compound parameter ID object and has searched within this object for any parameter that has the character MOLE. And I just have on here that this function is not case sensitive. It doesn't matter if you have if you've used small letters or capital letters. Okay, so now we're going to talk about how one is able to run a Simcyp simulation and save the results to a database file from R. And then we're going to talk about how one can go into that database file to extract the simulation results. To run a simulation from R, we use the function called simulate. Within this function, we need to specify the database file name. So in this example, I'm saving or I'm going to save my database file name as simcyp_DDI. And I've also mentioned the database extension, which is .db. Once I have run this function, what happens within your working directory is that automatically a database file will be created within that folder. After this, I can then make the RSQLite connection to this database file. For this, we need to use the package called RSQLite, and we use the function dbconnect. Within this function, you need to specify the database file name that you want to make the connections to, and then I've now saved this connection to an object called con. Once I've made the connection between R and the database file name, I can then go into this file to extract the simulation results. So as you can see on screen, I am interested in getting the age of subject 5. For this, I use the function called getIndividualValue. For this function, you need to specify the subject number, and then you need to specify the individual value ID. In this case, I'm interested in the age. Once you've done that, you then also need to specify the database connection. Once you've run this function, this will spit out in your R console the value of the age simulated for subject 5. You can also write the individual ID as a string. So in this case, the ID for age is ID age. If you're interested in just knowing the age value for the full population, you can use the function called getAllIndividualValuesDB to extract this information. For this function, you don't need to specify the subject number. All you need to do is specify the individual value ID as well as the RSQLite connection. Below is another example using body weight. So in this case, I'm interested in a body weight for subject 5. I use the function getIndividualValueDB, where I specified the subject's number, the individual value ID, and the RSQLite connection. Once I've run this function, it would spit out the body weight simulated for subject 5. And then if I'm interested in knowing what is the body weight for the full population, I can then use the get all individual value db function to extract this information. So if I'm interested in extracting a compound parameter, we use the function called get compound results db to extract this information. So for example, if I'm interested in extracting the fraction unbound in plasma, I use the function get compound results db, and it's to specify the individual number, then the results ID. In this case, the tag ID for fraction unbound is FUADJ. And then I need to specify the compound ID. So I'm interested in the substrate fraction unbound that was simulated. And then finally, I need to mention the RSQLite connection. If I want to split this information for the full population, I use the function called get all compound results db, where I don't need to specify the individual number. All I need to do is mention the results ID, so the tag ID for the parameter that you're interested in. Then you need to mention the compound ID, and finally the RSQLite connection. To extract concentration profiles, we use the function called getProfileDB. For this function, you first of all need to specify the profile ID. So in this case, I'm extracting the time profile that was simulated for subject 5. So you need to mention the profile ID. In this case is n times sub. Then you need to mention the compound, the individual number, the RSQLite connection, and finally, if you want the interaction profile. Um, then to extract the systemic concentration time profile, I use the same function, but in this case, the profile ID is different. In this case, for the systemic concentration, the profile ID is CSIS. I need to mention the compound ID, which in this case, I'm interested in the substrate concentration profile. And in this case, I'm interested in getting the profile for subject 5. I've mentioned the RSQLite connection, and I am saying that I am just interested in the profile without interaction with the inhibitor. Once I've extracted the time profile as well as the systemic concentration profile, I can then go ahead and make simple plots in R where I plot time against the systemic concentration profile. Assuming I was interested in knowing the concentration time profile for the full population, so in this example, we have 5 subjects. All one needs to do is to create a loop where within that loop, the individual number is being changed. So in this loop, what we have happening is that we're extracting the time data simulated for subject 1, and then we are then extracting the systemic concentration simulated for subject 1, and then we're saving it into an object called times and conc. Then when I changes to 2, we extract the time and the concentration data, save it into an object called times and conc, and then I changes to 3, and the same process is repeated for all the remaining subjects. Once this data is collected, we can then go ahead and make the plots for all the population within the workspace. Okay, so now we're done with the presentation. Now we're going to run through a Simcyp-R version 21 demonstration script. For this, I have already pre-written a script. Within the script, the first thing we're going to do is to read a Simcyp workspace into R. Then we're going to run a simulation and save our results to a database file. Once we've done this, we're then going to go into that database file and then extract the concentration time profile and then make the plots of this concentration time profile. After this, we're going to change some selected PK parameters. In this example, we're going to change VSS and fraction absorbed. Then we're going to rerun the simulation and save our results to a new database file and then make the plots again. The first thing I would like for you to just check is to make sure that you have the Simcyp-R Package version 21 installed in R. So the version number is 21.0.100. If you do not have this installed, please make sure that you do this by clicking on install. Then make sure you have zip file selected. And then from there, you go to the folder where the package is saved. Double click on this to bring this in and then click on the install button. And this should install the package into R for you. The second thing I want to point out is that make sure you have R version from version 4.0.2. In my case, I have version 1.2, which is okay, and it will still work with the Simcyp-R package. But make sure you have R version at least 4.0.2 for your R statistics. So the first thing in my script is that I want to clear my global environment. In this case, my global environment is already cleared, so I do not need to run this function. Next, we're going to now load the Simcyp-R package, as well as loading RSQLite package. The RSQLite package is required in order to make the database connection. So I'm now going to run these two functions. So that is done. Now the next thing we're going to do is to initialize the Simcyp version 21 simulator engine. To do this, I'm going to go into the package, and then I'm going to look for the function called initialize. Within this is an explanation of how to use the function. So you have the description, the usage, what are the different arguments, the values that is returned, and it gives a detailed example. So I'm going to copy the first one, which is initialized into Simcyp Simulator version 21, and the species that is initialized into is to the human, which is what I want to do. So I'm going to copy this line and then paste this within my script. Once I've done that, I'm now going to run this, and it should return saying that this initialization has been successful. In this case, it's returning true. If it's not successful, it would return the value false. Once that is done, the next thing I'm going to do is now to save my working directory to my script location. For this, I use the function called script location, and I save this into an object called path user, and then I now set my working directory to that path user. Now the next thing I'm going to do is to set the workspace. The workspace that I would like to bring in is called Simcyp-R demo version 21. So I'm just going to copy the workspace name from the folder just to make sure I don't have any typos when I do this. And then I'm going to paste this within the function set workspace. And also I'm going to type out the Simcyp workspace extension, which is .wksz. Once I've done this, I'm now going to run this function. And like I said in the presentation, it's going to spit out the summary of that workspace that you brought in. So in this case, the compound that is being used is alpha-fentanyl, which uses the first order absorption model with minimal PPK, enzyme kinetics for the elimination, and we can see that the dose value is 0.043 milligrams per kilograms, and it was given to healthy volunteers between 20 to 50 years old. So now the next thing I'm going to now do is to go and extract the VSS value used within this workspace. To do this, I use the function called getCompoundParameter. Once I run this function, on the right hand side, you will see that the VSS value within that workspace is 0.37. This can also be written using the string method. To use a string method, all I need to do is copy this. And then to know what the tag ID for VSS is, as I demonstrated within a presentation, all you need to do is open up the Simcyp workspace, right click on this input box, and then you can see the tag ID of this parameter. Clicking on this ID has already copied it to clipboard for me, and then as a string I can enter this tag ID in my R script. Once I then run this function, it's going to report that the VSS value used in that workspace is 0.37. I'm also interested in knowing what the FA value is. So I use getCompoundParameter function, where the compound parameter ID is FA, and the compound ID is substrate. And once I run this, on the right hand side, it's telling me that the fraction absorbed within this workspace is equal to 1. Once this is done and I've saved all my values into the objects I'm interested in, now I'm going to describe how one can identify parameter tags using list parameter. As I said in the presentation, If a parameter is selected for sensitivity analysis and you run the list parameter function, this will spit out all the tag ID that has been selected for sensitivity analysis within the workspace. So running this is telling me that the user input VSS was selected for sensitivity analysis. If I open up that workspace, as you can see, it has the purple triangle, sorry, on the left hand side, which means that this parameter has already been selected for sensitivity analysis. The third method of knowing how to identify parameter tags is by using the FindEnum function. So once I run this function, this has spat out all the parameters that has the character MOLE inside of it. And this was already described within the presentation. So now I'm going to run my simulation. I am happy with everything. I'm going to run my simulation. Within this simulate function, I'm also going to specify the database file name that I want the results to be saved as. So in this case, I want my results to be saved as demo results and along with the database file extension .db. So once I run this, the simulation will mention that it started. If it's successful, it would mention simulation complete. And if it fails, then it would not mention anything. So this is already done. And just to check, in my working folder, a database file has now been created called demo results. So now what I want to do is now to make the RSQLite connection to that database file. To do so, I'm using the function called dbconnect, which is found within the RSQLite package. So once I run that, the connection has been made and has been saved into an object called con. Now I can extract the concentration time profile for the population. So now I'm going to create empty vectors to store my results in. Here I am getting the population size, so the number of subjects within the workspace is equal to 100 subjects. So for all these 100 subjects, I am going to create a loop where I am going to extract the time data for all the 100 subjects. Then I'm going to extract the systemic concentration data for all the 100 subjects. Once that is collected, is going to be saved into an object called times and concentration. So this is already done. Once that is done, I am now going to now disconnect my database connection. So here I am now going to prepare my data for plotting using library data.table. Once that is done, I can now make my plots for my full population of my concentration time profile. So this has spat the concentration time profile simulated for all the 100 subjects. And just to make this bigger, this is the concentration time profile that was simulated for the 100 subjects. So now the next thing we're going to do is to change this VSS value. So I want to see how will this impact the predictions of my model. So I'm changing VSS to the value 2.3, where before the VSS value was 0.37 and FA value was 1. So I'm changing VSS to 2.3 and FA to 0.32. To change these parameters, I'm using the function called setCompoundParameter, where I'm mentioning the compound parameter ID, so the tag ID, as well as the compound ID, and then finally the value that I wish to change this parameter to. So in this case, I am calling VSS new, which is equal to 2.3. And once I run this function, I can now rerun get compound parameter function to just check that the VSS value has been changed to the new value. So this has been done. To change FA, the difference is that I'm going to use set compound parameter where the compound parameter ID is $FA. So once I run this, I can also check that to make sure that this change has already occurred. So now it's updated the FA value to 0.32. Once I'm happy with all my changes, I am now going to rerun a simulation using the simulate function, and I'm going to save my results to a new database file name, which I'm going to call demo results updated. Once I've ran this, it should spit out simulation complete if it's happy. And if you go back into your working folder, you should see that a new database file has been created and stored within this folder. So now I'm now going to make the RSQLite to this new database file. And then I am now going to extract the concentration time profile for all the subjects and save it into the objects called Simcyp-Pred-New and Simcyp-Pred-Conc-New. So that is now done. I'm now going to prepare my data for plotting. And then I am now going to plot my results. So as you can see, this is the updated concentration time profile once I have changed VSS value to 2.3 and FA value to 0.32. To have this plotted side by side, I'm just going to plot the average concentration time profile to just have a look and compare the two results. So once I've done that, I can see that when the VSS value and FA value was the original values, this was what the mean concentration time profile was for all the subjects. However, when I updated the VSS value and the FA value, the red concentration time profile shows the influence of this change to my model predictions. So once I am done with my script, I am now going to make sure that I uninitialize the Simcyp-R package. Okay, so that is it on the Simcyp-R demonstration. If you are interested in this script, feel free to send a request via your members area or to simcyp.support@certara.com requesting for this file, Simcyp-R Package version 21 e-learning video demo files. Once you've requested this, this file will be placed inside your members area. For further help on how to use the Simcyp-R package, please do make use of the help pages found within the package. All the list of functions have detailed explanations of what they do, how you can use them, and they also have elaborated examples for each functions. Thank you very much for your time.